questions about page 445, number 74. Through how many radians do the minute hand and the hour hand move between 1 p.m. and 6:45 p.m. on the same day? So on this problem, probably the first thing you guys are thinking about is, wait, we use digital clocks. So I know we're not very used to these kinds of clocks, the analog clocks anymore. So let's think here I have a clock set to 1 o'clock and here I have one set to 6:45, so we can kind of see what happens. Now we're going to do two different things. We're going to do the minute hand and then we're going to do the hour hand. So I'm going to do the minute hand first because clearly we know it's going to make a whole rotation, so that's going to go from 1 o'clock to 2 o'clock. It's going to go 2 pi because it's going to go all the way around. And we're just talking about, I know you might be looking at going, it's going in the negative direction, it's not measured in standard position. We're just seeing how many radians does it sweep through. So every time it makes a rotation, it's 2 pi. So 2 pi takes me to 2 o'clock. This takes me to 3 o'clock. This takes me to 4 o'clock. This takes me to 5 o'clock. This takes me to 6 o'clock. So now I'm at 6 p.m. and I have to go 3/4 of the way around. So if 2 pi is the whole way around, we want 3/4 of 2 pi. So then we get 3 pi over 2. So I need to add on another 3 pi over 2. So that would be the total number of radians my minute hand sweeps through. So if we combine this is 10 pi plus another 1.5 pi. I'm going to change this. 10 pi is the same as 20 pi over 2. That would be the same as 10 pi. So then you can kind of see with the common denominator, we get 23 pi over 2. And that would be for the minute hand. Okay, so now the hour hand. Now clearly it doesn't even go around a whole time. So we want to kind of think, well, if each increment, if 2 pi is all the way around, then what's just this partial way around? So starting at 1 o'clock, let's think about how many radians would be a 5-minute increment. Well, if you were to see how many 5-minute increments there are all the way around, so we have a total of 12 of them. So if you take 2 pi and divide by 12, you get pi over 6. So each of these increments here, for every going from, well, I guess we're going from a 1 to a 2. Each time I do that, I'm going to go a distance of pi over 6. So starting at 1 o'clock, now we're dealing with the hour hand. From 1 o'clock to 2 o'clock is pi over 6. From 2 o'clock to 3 o'clock is pi over 6. From 3 o'clock to 4 o'clock is pi over 6. To 5 o'clock is pi over 6. To 6 o'clock is pi over 6. But now what about to 7 o'clock? It's not the whole thing, because you know with the hour hand, it doesn't just automatically go from the 6 to the 7. It's 3/4 of the way. So because the minute hand was 3/4 of the way around, so the hour hand goes 3/4 of the pi over 6. So we have to figure out 3/4 of pi over 6, which is pi over 8. So we have 1, 2, 3, 4, 5 pi over 6 plus pi over 8. Common denominator, a little practice with fractions. So our common denominator would be 24. So if I multiply this one by 4 over 4 and this by 3 over 3, I'm going to get 20 pi over 24 plus 3 pi over 24. So we get 23 pi over 24. So hopefully that helps. I actually love that problem. I think it's kind of a really cool problem. So definitely the pictures help. Even I didn't have to put the little clocks on there, but it helps give you a visual. Hope you guys are having a great day. If you have any other questions, please let me know. I did this problem because I had 2 people ask me about, actually I think I had 3, asked me about it. I'm happy to do problems like this and get the information back to you.